Hi, hello everyone. Welcome to Versatile Data Kit meeting. Today is 28th of February, and we're going to talk today about how to build a RAG pipeline. And our agenda is here. I'm going to do a little bit introduction of VDK, what is VDK, our theme, and maybe some people who are using or are here also who want to introduce themselves. Then we're going to present the latest release of VDK. Dilyan is going to tell a little bit about what are the latest things that we have done. And then we have a RAG pipeline demo by Johan. And he's going to show the latest work that we have been doing on this topic. Yeah, I just wanted to say that community meetings are here to keep people who are interested in VDK up to date on what are the latest things that we're doing. We're recording these meetings and publishing them on YouTube. In this page, in our wiki, you can find all the previous recordings that we have had before with all the agendas and the themes as well. And yeah, don't hesitate to start a conversation. If you have any questions at any time, you can just unmute yourself and ask, or chat, or raise your hand. And yeah, I'm gonna just introduce quickly what is Versatile Data Kit. Maybe someone is here for the first time. Basically, Versatile Data Kit is a framework to develop, deploy, and operate data workflows with Python and SQL. And in our repository, it is open source and publicly available. In our repository, you can find a little bit more also about every feature that it has, but basically it does data ingestion, transformation, deployment, operations, and it is like extensible kind of Lego, like it's extensible with plugins. We also support our contributors. Any contributions are really welcome, and as well as we're searching for people who are using VDK. So if you are using VDK and you would like to give us any feedback, just reach out to any person in the team. And now I'm going to stop sharing. Just the team, maybe you want to unmute yourself and say a little bit who you are and what you are doing.
Hi, my name is Gabriel. I've been working on VDK for almost 3 years at this point, and yeah.
Thanks, Gabi.
Hi, my name is Dylan. I've been contributing to VDK for, I think, a year and a few months. Managed to complete some features that actually, I mean, there's a milestone for them in this release, so that's pretty cool, and hopefully lots more great things coming.
Hey everyone, I'm Johan. I'm maintainer of the project for a year now. I mainly focus on the VDK DAC plugin, Jupyter integration, and now the AI initiative you'll hear about in a couple of moments.
Hello, I'm Duygu. I'm a maintainer of VDK for almost 2 years now too. And I have been part of the AI initiative as well, but now I'm working on something different. And yeah, that's all from me.
Great, thank you. I also see Sabi here. She used to, or is kind of interested in contributing. Aldis was actually also interested in using possibly VDK. So I think also the topic is interesting in sense of like ingesting or what we're doing with the RAG, as far as I know. Okay, so I think maybe we can jump into the latest release and then demo the RAG. So Dilyan, I'm just gonna pass the word to you.
Can you guys see what I'm sharing?
Yes.
Yeah, so for release 1.7, some major features. This is actually a feature that I've been working on for a while, and it's a milestone for it in the sense that, I mean, it's done. At least it's feature complete for what we planned. The latest thing that we added is preset configuration, whether you want to have structured logging for local runs or for cloud runs. And this might be a topic actually for future community meeting, but VDK now supports a bunch of cool stuff like structured logging and different logging formats. The other great thing here, of course, we have some examples for using VDK to enhance your RAG pipeline, which are linked here. And this first one you will see a little bit later. We also have a chat API / chatbot demo that ties into this, and you can check it in the release notes as well. For VDK DAGs, to anyone who's unfamiliar, it's directed acyclic graphs, which means that you can have a couple of jobs that are arranged in a dependency graph, so you can better manage your job deployment. So for example, one job can fetch data and then other jobs can just ingest it, that sort of thing. You used to be able to do this only in the cloud. Now you can run it locally as well for testing or just for fun. And the other thing is we now have support for Python 3.12, which is pretty awesome. And yeah, you can use it to run VDK and VDK jobs. I will click release now. And hopefully it will work. All right, cool.
Okay, I also pasted the link to releases in the chat if someone is curious. And now I guess to the main topic of today, Johan.
Okay. So, yeah, the main topic for today is building a RAG pipeline with the help of VDK. And we'll all take a look at the great demo that one of our team members, unfortunately not on this call, made. So yeah, I'll share my screen. Just let me know if you can see it and also hear it.
Hi guys, my name is Paul Murphy, and today
We
Can you
see
hear it?
We can see it and hear it, yes.
Okay, great. I'm playing it then.
I'm going to show how the VDK can make your life so much simpler if you're trying to build RAG data preparation pipelines. So my goal today is obviously to show how useful the VDK can be. And how I'm going to do this is we're going to work on a pretend task. Your company has assigned you or your team the job of building data preparation pipelines for a RAG system. The where you need to pull the data from is a private Confluence, and it should be updated very often. So why would someone use this? Well, Broadcom or VMware might use this because they want to have a chatbot that people can use to ask questions, and the answers that the chatbot give can be derived from private information in your Confluence pages. These Confluence docs are used a lot, and that's why we have to update. We have to do an update every so often because we want the data to be pretty accurate within a 6-hour limit. Okay, if you go ahead building this, there are already a lot of tutorials on how to build a RAG pipeline like this. So we're just going to follow one of those very standard tutorials. What we're going to do is we're going to use LangChain for reading from Confluence and splitting the pages into smaller paragraphs so that we can create good embeddings from them. We're going to use Hugging Face sentence transformers library to create the embeddings. And then we're going to use Llama index to send that information to Postgres. So at a high level, this is what the pipeline would look like. Ask LangChain to get the data for us. Then it chunks it. Then we send it to an embedding API. And then the embedding API, after the embedding they're done, Llama index will send it to Postgres. So what would a solution like this look like? Well, I've built a very simple one here. So what we do here is we read from Confluence, we chunk the text, and then we create an embedder, and then we say, using that embedder, Llama index, insert it into Postgres. Now this is only really, well, I guess about 30 lines of code. And if you build this locally, you'd be pretty happy with it. You could run it locally and look at the data and see it. But now it's not so obvious how to get something like this into production. I can see a number of flaws with this. Firstly, I can see like, look, there's just secrets in plain text here. How do I handle these? The platform that I deploy my code to, I want that to manage my secrets for me. Also, we don't know how to run it every 6 hours. We're not going to just use crons on our local machine. This has to be deployed to a production cluster where multiple people can monitor it. So how do we set up this job so that it runs every 6 hours? And lastly, we want to be able to update this last modified by timestamp dynamically. So what this last modified timestamp does is it lets us say to Confluence, give me only pages that have been modified in the last X number, since this date. Using this, we can, if we use this intelligently, we can, on the first read, we can read everything, but then each 6 hours after that, we will only read the data that we haven't previously read. So when a job finishes, it should really write down the timestamp that it read up until. And then when the next job starts, it can take that timestamp and only read information newer than that. So how do we support something like this in our job as well? So that's 3 very obvious things you can see when looking at the code. But there are also like more fundamental problems with this code. Like how do I've written the code locally, but how do I even package it? And like I want alerts and monitoring on something like this. I'm just a Python developer. I know some amount of information about Prometheus, but really I want to make sure that this job is running stable, it's running every 6 hours, and it's easy to see that it's running every 6 hours, and I'll be notified if it's not. And VDK provides all this for you. So, okay, I'm bought into VDK. What changes do I need to make to my code to use the VDK? Well, that's what I'm going to show now. So the first thing you would do is you would install the VDK CLI by installing a pip package. Then you do VDK login, which I'm just going to skip, and then you will say VDK create. So let's create our VDK project now, our VDK beta job now. So the job name is going to be demo rag pipeline. And I'm just creating it under my team. Okay, as we can see here, it's created the folder for us with an empty configuration. So what I do is I take my requirements from my local run and I copy them into the requirements file for VDK. I take all my code and I copy it into the VDK run function. So now we have our code copied into our VDK job. Question is, how do we make this code production ready? And this is where VDK comes in. The first thing that in my opinion, that makes this code just pure test code and never something that would be put in production is the fact that there are plain text secrets in it. So VDK makes it very easy to handle secrets. You just save the secret to the VDK ecosystem using the CLI. So VDK secrets set. We're going to save the Postgres password first. So Postgres password. And then let's save that. Give it the name of the job. And the name of the team. Next, let's do the Confluence token. Lovely. Okay, so now we have to load the secrets using the VDK SDK. So we say job input dot get secret, and this is the Confluence token. And here we say job input dot get secret, and this is the Postgres PW. Lovely. So we've dealt with the secrets. The next thing we'd like to deal with is running on a 6-hour interval. So the cron is specified in the config file. So we go in here and then we just set the cron to be a 6-hour cron. I know that this is a cron that will run on the 0th minute of every 6th hour. And the next step we wanted to handle is only pulling new data, which we're going to leverage VDK properties for this. So the first time the job runs, it should pull everything for Confluence. But every session, every iteration after that, it should only pull new data. So how this is going to work is that a job at the end of it is going to save a state, which is the time that it last scraped at. And we know that we can just use that as the filter for the next run. So we'll say so here we first of all compute the last scrape time. Then we're going to load. We are going to load in the property, read the existing property. So we say get the property last modified. If it doesn't exist, use a time very far in the past. But if it does exist, use it. And then at the end of our jobs, we're going to say job. Okay, so that handles the keeping track of the state for us. Now we want to push this code so that it runs in the Kubernetes cluster. All we need to do is VDK deploy and pass in the path to our job. Now what's happening here is that the VDK control plane is creating a is packaging everything you've written up into something that is well designed to run on a Kubernetes cluster. It's creating a good Docker image with all your dependencies and all your code that's ready to be deployed and run. It's also creating the relevant cron job files and config files for you. So I'm just going to skip ahead now to when the deployment is complete. So after the deployment has completed, you will be able to see your job in the Super Collider UI. So we go into data jobs. And we can see our pipeline. It's designed to run every 6 hours on the 0th minute. What's actually happened is I've pushed this job previously, so this will make the demo more interesting. If we go into details, we can see that there's been 4 previous executions, and it's going to run again in 5 hours. The last 2 have been a success, but the one before that was a user error when I was just building the job for the demo. If you want to see why it was a failure, you can go into logs, and it will bring you to VMware Log Insight. This is really nice. Like, you're automatically well integrated with the rest of the VDK, with the rest of the VMware like ecosystem and stack just by running on the VDK. Your alerts go to the standard places that VMware and Broadcom alerts go to. Your logs go to the standard locations. It's just a very plug in and play ready. Also, each time you deploy your code, we save it to GitHub, so it makes auditing very easy. The VDK, the Super Collider on VDK also supports lineage. So if you start using those embeddings for different tasks like clustering, you might want to keep a lineage of where the data is going and what it's used for, so that when there are issues, it becomes easier to track down the source of those issues. So this is just a very important side benefit of the VDK. When you deploy with the VDK, you can track your job deployment status. You can see execution management and insights. So here we can see, look, this job was started manually, and the next one will be started using a cron. You can see success rate metrics, access to logs, and scheduling visibility. So I think that's a really good benefit. So, but let's go back to the core benefits. Now we've deployed our job. And as you can see, it was just 1 or 2 commands on the CLI to run it. So this makes you get all the benefits of Kubernetes without needing to get bogged down in the complexity. We handle that for you. We handle the scheduling. We handle the state managing, monitoring, and alerts are well configured out of the box, and we have good secret management. And what's more is we provide you with the flexibility to use whatever libraries and frameworks you see fit. If you become more invested in the VDK ecosystem and want to leverage more of the features that we provide, we also have DAGs. So I don't know if you're familiar with DAGs, but DAGs are directed acyclic graphs. They're very popular in Spark. And so you can split up the job into separate, more modular components. For example, one job could be responsible for fetching the data, one job responsible for chunking, one job responsible for embedding the data, and one job responsible for writing it to Postgres. You might find that the chunking job can be shared between pipelines because it's the exact same code for chunking Confluence versus chunking Jira, or embedding Confluence versus embedding Jira. So that's just some of the more advanced functionality that you might want to leverage if you start using VDK. Another very important benefit of VDK is that it's API driven by design. So the versatile data kit, like the control service API, streamlines and manages key stages of the development lifecycle. So deploy data jobs with single commands and manage and operate them through the APIs. We have APIs for registering jobs, changing the source code of jobs, deploying jobs, getting the status of jobs, and updating properties and secrets. Here's our Swagger documentation. As you can see, it's very well documented, it's very clean, it's very easy to play around with. And it has been designed for other teams to use.
Okay, so that was the end of Paul's demo on the topic. And I want to now show you a bit more on the different stages of the pipeline. So you by yourself can check out our examples in the VDK repo, which are, there is example for the Confluence reader, which is basically the job that, the part of the pipeline that fetches the data from Confluence. You can test it yourself. Then there is the chunker example, which does the chunking of documents, splitting them into smaller parts. And here it is, the chunker one. And then we got the PG Vector embedder, which is a plugin, which is a data job that embeds the data, the documents you already fetched, and then ingest them into Postgres with PG Vector extension. So yeah, you can play around with those examples or build your own pipeline. And here is an example DAG job that combines the Confluence reader and the PG Vector embedder. And we could add the chunker in between the two as well, if you want to chunk the data. And yeah, I think that's it. Let me know if you have any questions.
Well, for sure, I think the first question that comes to my mind, because this demo was kind of created internally, I think for VMware and Broadcom, like what is the difference and is everything available for open source? Like what does this mean for open source community?
Yeah, great question. So the differences between this demo and what would actually be the case with for everyone is that the UI would be very similar to this, the VDK UI, but there would be some small changes to it. And about the walks, we saw that Paul clicked on walks inside the UI that was leading to Walk Insight, which is a VMware walk management solution. Well, basically, you could integrate with your own management solution instance that you got. You could use any kind of walk management solution you want. It doesn't have to necessarily be Walk Insight. And this is what's difference. This one that Paul demonstrated is internal instance that we got, Walk Insight instance. So yeah, apart from that, I think everything else should be the same for the open source community.
Okay, so the Super Collider, is that also available open source?
No, that's an internal product that, we used the UI of it.
And then on the top right corner of the Super Collider, I suppose there was some other tool named, is that to manage the hardware, GPU cards and stuff? InstaML or something like that.
Yeah, I mean, That's a internal platform basically for machine learning.
Mm-hmm.
But this UI is available open source. So basically when you
Yeah.
install you just, it's not called Super Collider, but basically you get this UI for yourself for logs and monitoring the jobs and alerts as well.
Mm-hmm.
Yeah, when basically you deploy the VDK UI, you can configure it to work with different internal system you have. For example, if you have Walk solution, you can configure it with your Walk solution. In the example, it was just Walk Inside. If you have Jupyter Hub installation, you can also configure it with your own Jupyter Hub installation. In the example, this was called InstaML.
Mm-hmm. The new data every 6 hours. So I'm thinking about the refreshing in the vector database. Does it actually get refreshed like it would be the latest version of the Confluence? How does that happen? Or does it keep pushing the new changes on top of the old ones?
Yeah, so basically it replaces the ones that got modified in the last 6 hours by the latest changes of them, the latest versions of them, of the Confluence pages. So basically, let's say, sorry.
Yeah, continue.
Yeah, basically, let's say you got a Confluence page that you already got into the vector database, but then before the next scheduled run, you decide to change something in this page. Then on the next run, it would be updated into the vector database, and the other one, the previous one, deleted.
The whole page would get refreshed, you say, yeah?
Yes.
I don't know how vector databases work generally, so it keeps that relation between the original page and the vectors somehow, and finds in the database the right places, deletes them, and uploads the new embeddings, something like that.
Yes, it keeps the ID of the pages basically, and navigated by this ID. It just takes the pages that were modified and deletes them and replaces them by the new versions of them. By again chunking them and embedding them and then ingesting them into the database.
Yeah. The secrets that Paul created, where do those get stored at the end? Are those Kubernetes secrets at the end or what? Kind of he created them in the console and then he uploaded the job. Those secrets get uploaded to the cluster so that others can reuse them, I suppose, in a shared manner without seeing the details. But where do those get stored? In what form, actually?
Yeah, Tony, do you want to take this one?
Yeah. So yeah, basically, when you install VDK server, you come with a couple of APIs as Paul showed. Two of those are called Secrets API and Properties API. Properties is meant to keep state. It's backed by a database behind the scenes. And Secrets API is meant to keep, well, secrets, as the name suggests, and it's backed by a HashiCorp vault behind the scenes. And you can use the API or the CLI, and potentially in the future the UI to set and manage the secrets, and then you can consume them in the job using the, as Paul showed, job input get secret interface.
The HashiCorp.
As far as I know, they're not shareable. Sorry, you also asked about this. Like they're per job.
Per job, but still the team uses the same job, but in this way it gets shared.
Yes.
Yes.
Okay. You just mentioned HashiCorp Vault. Does that mean that it's kind of included as part of the VDK, or this is for this setup specifically?
No, it's included as part of the VDK. If you enable it, when you install it, you can decide to enable it or not.
Uh-huh. Okay, I didn't know. All right. You didn't show the chatbot at the end. There was a promise. Okay, not important.
Yeah,
Hi, this is Suresh here. So, the framework that you are showing, right, is it only applicable for web pages or a web portal, or is it something like we can able to have the multi documents, images, everything that we can able to form it from the RAG?
sorry, can you repeat the last part of the question? I think I got it most, but
Yeah, so is this only this framework, right? Is this applicable only for the Confluence or kind of a web portal, or it's applicable for documents and images as well?
well, this example shows how to do it with Confluence. You can do it with Jira. You could do it with any other source that you got documents. Like basically, you could, if you got already the documents, you could skip the first fetching phase and go to directly to the chunking one and then embedding and yeah, any kind of documents you have.
Okay, so for example, like we have a set of documents that was processed, and if the same document comes again to this pipeline, is it anything like it will auto sense it is duplicate and it will ignore? Is there is any kind of mechanism is there?
So I'm not sure I quite understood, but I'll try to answer that. Well, basically, if the document comes again, you would have to have a way to see when this page or document was last modified. If you don't have such way to see this, then basically it wouldn't be. It would be just a replay. You could make it to be just replaced by the old one with the new one. So it would replace all the documents and not just the modified ones if you don't have a feature for metadata for the last modified timestamp.
Okay, thank you.
No problem. Any other questions?
But still, in regards to chatbot, is it something that we have done actually, or this is just like something that we're planning to do for this example?
Well, for the chatbot, we've set up a very quick one just to verify that the data preparation pipeline that we are focused on is working, but the focus is basically on the data preparation pipeline. So yeah, that's what we got. I can actually, I'm not sure I showed you. I can also show you the database, the vector database, what we got in there after the ingestion, after the end of the pipeline. But right now we don't have prepared chatbot UI. So yeah, here are the chunks of the text chunks that we got. Here is metadata regarding the on document level metadata. And here are the embeddings, the vectors that we got for each text. So basically when the page is updated, then all the chunks that are with this ID, the same ID of the page, are being deleted and replaced. The entries are replaced by the new ones.
So this is for upload then kind of static information which is changing and we check it every 6 hours. What about the chat history? If we think about chatbots specifically, does VDK provide a solution for that as part of this whole bigger solution? Or what would you suggest?
I think this should be part of the after this pipeline. I mean, on the inference part, and VDK is not focused right now on that.
Yeah, VDK's focus is on building the ETL data pipeline, which is how do you get all your different data, Confluence, PDFs, whatever, prepare them, clean them, and index them in a vector store, chunk them, and so on. And then the inference part, or the part where you build your chat API, is not something that VDK has ever, is separate, you probably won't running service. I can show you how, for example, you can build a chat API. I have, if you want, I have it working on my machine. So let me share.
Yeah, okay, let's look at it. I'm just thinking, what's the best way where to keep chat history? And if I do have a VDK, shouldn't I be using VDK also for that? Because it's just another type of data.
So, for example, if you have configured the vector store, when you're building your chat API, you need to provide one thing is where is the vector store location. The other thing is which large language model you use. There's some internal one, but you of course you can use OpenAI, ChatGPT, and the name of the tables, which are stored in the vector store. And once you do, here the chat API is pretty simple, fast API chatbot based on Streamlit. It will be able to start. So, and then you can ask it questions, right? What's a data job? How to create a data job, things like that. Since the bot was trained on superquider data, here you see some superquider related data. The idea is that you train to some kind of internal data, right? And here it explains how do you create, run, and deploy data jobs, for example. And you can now communicate with it. Yeah, basically all you need to do is point your the way you do the inference applications could be very similar for different use cases. You just point it to the correct vector store and LM that you want to use. You can apply some other strategies and that would start working.
Yeah, okay, thank you. My question was about the chat history specifically, but
Oh, yeah, well, for example, in this case, Streamlit automatically keeps chat history and embeds it into the next question. But this is part of the sort of the UI, the chat API implementation. And that's not something that VDK would handle.
so the history is not in the context when you ask the next question. Well, it depends on the app. Oh, okay.
It could be, but it depends on how
It
the
could
chat
be,
app is
yeah, it could
implemented.
be.
It's part of the implementation of the chat app itself.
Mm.
So just looking at it, looks like it could be something nice to have actually if I would want to use VDK and I could actually ask these questions from the documentation, just will be the easiest way maybe to go through or getting started or something like that. So I don't know. Can we have an actual chatbot like this somewhere?
This is actually a huge use case right now, like for internal documents, especially at large companies, where maybe it would take you months to plow through all the relevant documents. You can just have something like this and then ask it questions.
I think a Git idea though specific for VDK documentation. If we can training basically cost to share this kind.
Well, yeah, it actually applies to us as well, right?
Yes.
Yeah, that's what I meant. Because it looks like very simple. Like you just ask question like how to create a data job, and yeah, gives you an answer. It's just something that could be actually useful for our open source project or whatever, not only internally but also externally.
Yeah.
So I believe you've been experimenting with the RAG a bit. What is your experience? What happens if, let's say, in this tree of Confluence pages, we have the right answer in, let's say, 5 different pages, just because it's people, they have documented the same thing. What is the result you get back from the RAG solution? I mean, you ask, how do I use the VDK, and it's described in 5 different Confluence pages. What happens?
Well, basically, the embeddings are being ranked when you have a query. When the user searches for something, this query is being embedded, and then based on the similarity between the query and the data, the embeddings that we got in the vector database, the top results are being taken into account, and then the large language model that's doing the inference basically takes information from the context that's being provided. The context might be top 1, top 2, top 3, or let's say top 5 documents. You set it, and well, if there are multiple documents, then the large language model would most probably take the information that comes from the most relevant one, the one with highest score, similarity score between the query and the embedding of text chunk.
Thank you. You clarified this for me. Okay. Well, yeah, thanks.
Okay, are there any final questions that we can answer? If no, then yeah, thank you. I think this was a really great demo. Thank you for the questions. I think it was very relevant and an interesting example, and yeah, positive.
Hope this recording will be shared, right? Sorry to interrupt. Recordings for this meeting will be shared?
Yes, I'm gonna share my screen, quickly show you where exactly they are shared and where you can find them. But basically, you can just search for YouTube and Versatile Data Kit. Give me a sec. So basically, if you go here to our repository and you go to wiki page, on the side you will see community meetings. Maybe this is like the easiest way to access all the meetings with everything that is the content, and it's going to be here in this page. There is like the collection of all the meetings in chronological order that we have had. And if you go to one of them, you will see our YouTube channel. And here on the YouTube channel, you will see all of the community meetings are here in the community meetings playlist. But there are also some others. There are some getting started, really short videos, and how the operations UI looks like, and maybe also some tutorials that you can use to get started with VDK. So everything that we have basically is here. And yeah, we also really are really happy when people are supporting us. Like if you haven't started our repository, also you can support us by by adding us a star here, and that also helps us to be a little bit more visible for the community. Next meeting, and usually community meetings we're having at the end of the month, just follow our LinkedIn page or also in this wiki page, we're also usually announcing them. So thanks everyone for joining, and have a great rest of the week.
Thank you.
Thanks, everyone.
Right.
Everyone.